All right. So I've got 105 on my computer, so I'm going to get started. See here, just make sure everybody can hear. Today, as you may have noticed last week, I like to start by looking at the calendar, see what's coming due. So today is January 13th, which means tutorial 1 and tutorial 2 are due this weekend. Assignment 1 has been released, and that is due in 2 weeks. And then tutorial 3 will be released next week. And there's always a possibility that the tutorials get pushed back depending on what other things we have going on. So just keep an eye on those due dates. Tutorial 1 you should be able to do. Tutorial 2 will require namespaces, which we might not get into until next class. But I mean, you can always take a shot at it and see what you can do. Yeah, so assignment 1 has been released. I might talk about it a little bit today after we do some, finish off the last lecture. But yeah, any questions before we get started? Okay. So last class we were talking about basic language features, right? So nothing too in-depth yet, but what is at the sort of foundation of C++? And we had gotten to here, which is the blocks and local variables. There's a test. Yeah, so hopefully an easy test, right? So test 1 will be in 2 weeks, which means that, right? So one of the reasons why I did it this way is so it's sort of staggered with your other midterms, right? So midterm season is generally speaking here and here. And so test 1 falls nicely outside of that. It should be kind of a short test and based only on the things you did in assignment 1. And in some sense, doing your assignment 1 would be a good way to study. But I will also release a practice test next week sometime. And that we'll go over and talk about. Again, there will be some handwritten coding. And I was thinking maybe some multiple choice based on like some of the WooClap. Like I just directly take these questions off of WooClap and give them to you as multiple choice, since that would be like the second time you've seen them. So that's one idea I've been entertaining as well. But yeah, I will talk more about test 1 in the coming weeks. It is in person, yes. I only do tests in person, none of this online. I mean, the averages for online tests versus in-person tests are vastly different, right? And obviously, like everybody knows why that's the case, which is why I only do in-person tests. Right. Other questions? Again, I'm going to cover this in more detail in the coming days, but all right. It shouldn't be difficult if you do your assignment 1 and then take a look at the practice test and make sure you can do all the things there. I don't think you'd have a problem. My goal with tests is never to, yes, you're going to have to write code by hand. My goal with tests is never to make it difficult even. Like it's basically like, did you write your own assignment? That's the test, right? So if you've written your own assignment, then this would be the second. And if you did the practice assignment, then it's the third time you've seen a coding question that looks exactly like that, right? So that's really, as far as I'm concerned, that's what the test is for. If I could just give you assignments and be absolutely certain that everybody did their own assignments, that would be ideal, right? It would be ideal if everybody just programmed, we do one big project or something. But of course, there's practical considerations to that. Anyway. All right, so we were talking about basic language features, and in particular, we're talking about blocks and local variables, and this is, I'm going to go over it again just really quickly, right? But there is this idea of if I declare an int x here, and then I have a block that's within, and there's some block here, right, that I haven't written. Maybe there's a main block, and then within that main block, I declare this int x, and I give it a value. And then within this for loop block, I declare another integer x. Well, these are 2 different variables. And inside my for loop, I can only see this one, right? I've effectively hidden the previous declaration of x from scope inside the for loop block.
Oh, this meeting is
Once
being
I exit the for loop block, this gets deleted. And again, I have access to this X.
يعني
So when I do C out here, it's going to print out an 8. And then there's a similar setup and resolution here, but let's take a look at the code. So I'm going to do something very similar, except one slight difference. I'm declaring a variable at file scope. Right? So this is actually a global variable X. Other than that, file scope is valid. It's outside of any block, which means that it's a global variable. I can access it from anywhere in my program. Well, with a couple of caveats, right? But I have to be able to tell the compiler about it if it's in a different file or something like that. But technically speaking, this is a global variable. And then inside my main function, I declare another variable X, and then I can print out that X, right? So let's just start with that. And then, yeah, so P3, that's not, I didn't save it. Okay, so the first X is 8, right? So I declared a global variable 10 at file scope, but now I've shadowed it here. I've declared another variable X inside the main function, inside that block. And so now when I reference X here, it's that first X. Okay. Now I'm going to have a while loop, which is, while loop, for loop, essentially the same control structure, just sort of it looks a little bit different. And inside I declare this variable X, and I assign it the value I, and I goes from 0 to size, less than or equal to size. So from 0 to 5. And so I'm assigning this variable X, the value 0, 1, 2, 3, 4, 5. And then once I exit the block, I'm going to print out X again. And again, I get 8 because this is a local variable to that while loop block, right? So as soon as I exit that, and in fact, every single time I loop, it makes a new variable X, allocate space. Now, the compiler is pretty smart, so it's just going to allocate the same location over and over again, so it doesn't have to do any extra work. But each time, that variable X is going to get a value I, and then on the next loop, it's going to be not deleted, but gone. As far as the compiler is concerned, we don't have access to it anymore. And then once we leave this while loop for the final time, well, this X is again this X. All right, so that's scope and shadowing, and one of the reasons why we use namespaces is to avoid naming collisions like this, right? Because this could be a problem if I really need to access this variable X from inside here, and I've accidentally shadowed it. But yeah, any questions so far? Okay, so there's one special case which we haven't dealt with, which is this file scope. So why is this here? Why should we care? Well, I can take a print statement and I can put it above this declaration, and then the first reference to X would be from this global variable. Technically, everything after this, that global variable is being shadowed, but global variables are special in that I can access them anywhere, anytime, right? Which means that, you have to watch out for things like naming collisions, because now I can't resolve them. But, and in fact, your code won't compile if I have two variables X declared at file scope. But I can use this, what's called the scope resolution operator, which is this : which we've seen probably a little bit before. We're going to see a lot more when we get to classes. And this says, grab me the X variable from file scope. Grab me the global variable. So when I run now, my last X is actually 10. It's referencing this global variable. Okay, and I can even, if I wanted to from in here, I can say, assign the global variable X this value. And then when I get to the end, my global variable has been assigned the value 5 on the last while loop. Okay, so that's the basics of scope and shadowing, and our special case of global variables where I can use the scope resolution operator to reference them. Right? We're going to use the scope resolution a lot more when we get to namespaces. Right? You've seen I mean, you've seen it for, if I don't use using namespace standard, then I have to reference cout this way. So this is just telling the compiler, hey, where do I find this variable? Well, you're going to find it in the standard namespace. And in the case of X, you're telling it, well, you're going to find it at file scope. All right, questions? Okay. All right, so let's look at some other basic language features that are going to be very important. So yeah, block scope, declared in a block, local to that block. These are local variables, and they can be blocks within blocks. You can have local variables, as deeply nested as you like, until you collapse, overflow the stack. And then you have variables at file scope, we'll say, which are global variables. They're declared outside of any block. We're going to learn how to use them. Kind of, you should stay away from them. Now, every rule I give you is sort of meant to be broken at some point, right? These are just best practices. Generally speaking, you never want to use a global variable. If you're prototyping, though, like, yeah, absolutely, throw a global variable in, get what you're trying to do working, and then later go back, take the global variable out, and put it somewhere appropriate, right? So, don't let these rules tie your hands when it comes to programming. All right. So input output. So we've seen some of it. We'll look at a little bit more. So input output streams in particular. So we're going to, if we want to write things out to the standard output, so the console, and read things in, we're going to include the IOStream library. It is in the standard namespace, so we either have to say using namespace standard or scope it in explicitly. The main object we care about in terms of output is the cout member. It's an object with reference to the standard output. You can actually redirect this, right? This is what I do in my, so there's a tester class that you got with your assignment 1, and inside the tester class, I redirect the standard output and capture it in a string, and then I search through that string to see if you printed the correct stuff, right? So you can redirect it, but generally speaking, by default, it's going to go to the console. Yeah, and there's some other details there, not super important. The input member is cin. So this is a member of the input stream class. So if I want to get input from the user, I'm going to use that. Now these things, and the standard error output, which is the console. You can redirect this to a log file with like one line of code, but by default, it goes to the console. The thing about these is that the formatting happens automatically, and we're going to talk about why when we get to operator overloading. I'll give you a little bit of preview here. But previously, when we were dealing with C, we had to use printf, and we had to tell, we had to give hints to the compiler, like, look, this is going to be, format this like an integer, or like a character, or like a float. But all of that happens automatically for us behind the scenes. So I've included the input-output stream library. I'm using the namespace standard, and so maybe I want to say something like, to the user, enter 2 numbers. And yeah, we don't need an end line there. And then I'm going to say, well, let's declare 2 variables for the user to input, x and y. And then I'm going to use, so this is the stream insertion operator, right? So it's an operator, the same as like a plus sign is an operator, or, I don't know, an arrow or a dot operator. In that, it's basically calling a function where the one argument is the standard output and the other argument is a string, right? And then this is just a function, and it runs in the background and outputs this enter 2 numbers to the console. When I want to grab input, I'm going to use cin, and I'm going to use the stream extraction operator, which is just arrows in the opposite direction. And I'm going to say, well, read me an x, and well, the nice thing is I can kind of like chain these 2 operations together. So read me an x, and then read me a y from the standard input. But these are ints, and so I don't have to explicitly say, like, format them like an int or expect an int. I just have to give it an int, and then the compiler is going to say, well, if you get an int, great, I'll put it in this variable. If you don't give me an int, well, we're going to flip a bad bit, and we're going to abandon this, right? So you won't get any useful information in your variables if you give it a character, right? All that's handled automatically for you. And then I'll put, you entered X, and then comma, space, Y, and line. All right. And again, you don't have to explicitly format it if these were floats, although, there are libraries to help formatting, but it will just recognize that these are ints and do that for you. Okay, so P4, please enter two numbers. Okay, so I can enter 4, enter, and then 5, and it tells me I entered 4 and 5. How I separate these numbers is sort of flexible. I can enter them both on the same line and then hit enter. I can actually, if I'm feeling particularly mean, I could enter a bunch of numbers. It's going to read the first two because it's only set up to read the first two. The rest of them are going to be sitting on the input buffer, waiting to ruin somebody's day the next time they try to grab some input. But yeah, you can do that. So yeah, separators in terms of input is space or enter or tab. The conversion from like a character to an int or to a float or to what have you happens automatically for you. You don't have to do it. When we get to operator overloading, we'll talk about how that happens. And yeah, that's questions. Okay. It's nice. It's elegant. I kind of like this style. There are pitfalls, obviously, with buffers, as there always are. But so functions. This is another feature of the C++ programming language. In C++, we have two kinds of functions similar to Python, right? So Python has global functions, and then there's also classes, and you can have member functions. So global functions belong to everyone. Member functions belong to a class, or a struct, or the same thing in C++. Although we're going to, kind of stick to classes exclusively from here on out. So global functions from 2401, C used exclusively global functions, right? Everything in C, there's nothing private. Functions belong to everybody. Data types belong to everybody. There's a function, you just call it, you give it the arguments, and then you get back some value. In C++, these are defined outside of any block, except perhaps a namespace. We could put them in a namespace. I almost put namespaces on the first assignment, and I decided against it, kind of regretting it now, but maybe we'll put it on a second assignment. You can call from any function or any class in the program, right? So main is it's not really a great example. It's one that you would want to call, but it gets called automatically for you. Member functions. So, if you're programming in Java, everything's a member function. Everything's part of a class. So this is defined within a class. It is considered to be a behavior of that class. We can call it by using an object that exists, and we can call that function on that object, right? Or there's also static member functions that can be called on the class itself, which we'll see later. So functions have a function declaration. So this is the prototype or specification. Recall how we told the compiler there was this foo function, and we just gave it the specification, the prototype. We just said, this is what it looks like. This is all the information the compiler needs to ensure that you've called it correctly. I didn't give it any implementation, but it gives me all the details of how to call it. And if you're going to document your function, like this is the place to do it, right? So, it does foo. Because typically, you're going to give the user of your class the header file, and you're going to keep the source file for yourself and give them an object file, like just the compiled code and a header file, and that's all they really need. So in addition to a function prototype, somewhere there has to be a function implementation. This is the body of the function, the code that executes. In C++, we tend to put these in different files because, again, we want to give the header file to somebody. It's enough information for them to use our library. And then we're going to compile the source code separately for them and then just give them the compiled version, right? So that's what you do when you make a library. You compile it for them, and then they have this information about how to use it and the source code, and that's all they need. All right, so a couple things about function design, right? So again, these are heuristics. So these are like best practices. These are rules that made to be broken at the right time, right? So don't take them, again, don't tie your hands with these things, but typically you take in data, process the data, and return a result. In C++, the return values are pretty popular, or sorry, output parameters are pretty popular. Return values are also popular, but historically they've been used more for indicating error conditions, right? So return false because something went wrong, things like that. Or an integer, it could be an error code. But as a general rule, functions should be single purpose. Sort of, you shouldn't try to do a million things in a function because, well, it's going to be hard to read and it's going to be hard to use. There might only be one use case for it, right? But if I keep things to a single purpose, that means they're going to be simple to write. I can write debugs. I can write tests for it easily. I can write documentation for it easily. All right. More good function design, encapsulate unnecessary details. This is sort of, again, in C, everything's public. In C++, we start to hide things from users. Divide large tasks into helper functions. Functions should be reusable. Again, mileage may vary, depends on the function. But certainly like the standard template library, when they design that for a broad use, right? People use vectors everywhere. All right. Output parameters. Return values and output parameters. So we're going to see an example of output parameters coming up. You guys are supposed to use an output parameter in your tutorial 1. So what is an output parameter? Well, basically we are going to, why do I have so much written here? All right, so I think an example is the best way to demonstrate this. So when we're passing in parameters to a function, we can pass in parameters by value or by reference. And all right, so what that means in C++, or sorry, in C, that means I either just declare the, I say struct of type whatever, student, stu, right? That's how I declare it. If I'm passing by reference, I need a pointer, right? So that's what a reference means. I'm giving you the address of the object. If I say foo, student stu, this is passed by value, and that means that when I pass in a student, it gets copied into that function, right? So the parameter inside my function, I can use stu as a variable, and whatever student I pass in gets copied into stu. Whereas when I pass by reference, I'm passing in a pointer to stu, which means that I'm actually passing in I'm making a copy of the address, but I'm giving you the actual object itself, right? So that's the main difference between pass by value and pass by reference. Pass by value makes a copy of the parameter. Pass by reference gives you the actual parameter, like the actual variable that you're passing in. And so we talked about this. I think I have to go through all my slides and start, trimming some of this stuff. So in C++, pass by reference can be done via pointers or references. In C, it's only done by pointers. So we're going to see a reference. Reference is sort of new to C++. Behind the scenes, it behaves a lot like a pointer. As far as the compiler is concerned, it's a pointer, right? The syntax is a little bit different, but behind the scenes, we are passing by pointer. We're just doing it in a clever way. So let's take a look. So I have my function declarations, my prototypes, and you'll notice that I've passed in an int here and here I passed in an int ampersand, right? So this is, I'm passing that second parameter by reference, right? And you can kind of think of it, if you're familiar with C, it's a lot like this, but the compiler is going to do some tricks and just make it seem like we are using a plain old variable. Okay. So I'm going to loop basically and grab input from the user, and I'm going to check to see that that input is okay. All right, so I'm going to, this check num function we see here takes an integer by value, right? Because I pass by reference if I want to pass in an integer, have the function make some changes to it, and then I get back that integer with the changes made to it, right? So if I want to change a variable, I'm going to pass by reference. If I don't need to change it, I'm just going to pass by value, right? I just want to, this num is just a value. It's not going to be changed in this function at all. If I look at check num, it just makes sure that this is between 0 and 100. But at no point do I actually have to change n, right? I want to leave it at the same value that it came in. So pass by value is perfect for this case. All right, so I keep going until I get a good number between 0 and 100, and then I'm going to double it. And you'll notice there's no return. I didn't use any return values here. I didn't assign the value to a variable. What I did is I have just a regular int result, and I just pass it as I would any other. There is a fundamental difference in that inside double num, this result, I'm going to assign it a value, and that value is going to be reflected out here. Whereas this num, I mean, let's demonstrate this explicitly. Okay. So I call double num. In my double num function, I pass the one res by the result by reference and int by value. And here I say res equals 2 times n. And then just for fun, I'm going to put n equal to 0. Okay, so inside my double num function, I've changed the value of res and of n, which is the variables I passed in are num and num result. So enter a number, yeah, so if I enter 101, it repeats, so it's going to check the number until I come back with something good, and then I'll put 33, and it doubles my number into 66, right? So this is an output parameter. I change the value here, it's reflected in the variable that I use to call it, right? So result gets a new variable, whereas num, I passed it by value, it made a copy of it, right? So it made a copy of it, it copied the value into n, which is just a local variable. I changed n to 0, but since n is local to double num, it had no effect on the actual value, right? So pass by value, pass by reference. Pass by reference, it's an output parameter. Pass by value, it's just an input parameter. Or, you know, output parameter or a big object that I don't want to copy. All right, questions? Okay. I have a version 2 here. Simply because you don't have to do this, but I do tend to get asked this question of like, well, what happens if somebody enters, I'm asking for a number, what happens if somebody enters a letter, right, a character? Well, it's going to crash. It's not going to crash, but your CN will become unusable because the fail bit is switched. So if you wanted to do a more sort of complete, you know, robust way to do this that doesn't always crash as soon as you enter something other than an int, you can check for this fail bit, and if the fail bit is flipped, you're going to clear the fail bit. All right, so this is just, the fail bit says like somebody entered something that they weren't supposed to, and I'm going to say, okay, that's fine. I'm going to clear it, and then I'm going to dump everything off the input buffer, right, because there'll be some stuff left there. And then I'm going to repeat this. For your assignments, you don't have to do any of this, but some people invariably are interested in how you would do it, and this would be one way. Now, surprisingly, you could probably still break this. Like there's users are terribly hard to predict every wrong thing they're going to do. It's crazy, but yeah. Questions? All right. So these references. So what is actually happening? So let's say that we have these two functions, main and some math. So in my main, here, let's go here. In my main, I declare two variables, n1 and n2. These are on the function call stack. And so they get the values 10 and 8. And then I call this some math function. So what happens? Well, the first argument is passed by reference, which means behind the scenes, I'm actually passing in the memory address. So the memory address of n1 is 0, 0. So this is behaving like a pointer. Even though the syntax is that of a variable, as far as the compiler is concerned, I gave a memory address, and then it figures out the rest. n2 is 8. It copies the value of n2 into num2. So num2 is now a local variable with a copy of the value of n2. And num1 is actually a reference that points back to this variable. Okay, so then when I do num2 equals num2 minus 1, well, this is going to decrement this by 1, right? It does not touch n1 because it's just a copy. And then I'm going to say num1 equals num1 plus num2. So it's going to take, well, num1 is just pointing to this memory location. Sorry, that should be 10, right? So it's going to say it's equal to num2, which is this, 10 plus num2. So this is going to be 17. So behind the scenes, that's what's actually happening. Another way to write this would be, well, when I call my some math function, this just becomes a reference to num1, right? So it's an alias. So I have the same variable, n1, just has two names, n1 and num1, which we're going to actually see because we pass by reference for output parameters, and we pass by reference when we're passing an object that's big and we don't want to make a copy of it. But we can actually use references outside of parameters, right? So yeah. All right, so we'll get to that. So pass by memory location, which is essentially pass by reference. We can use pointers, which we didn't see here. We're going to use that a little bit later, but you guys have seen that in C, right? You've passed things by pointer. It's powerful, somewhat natural, easy to make mistakes with, right? I can send a null pointer or something that's an uninitialized pointer. That's bad. References try to avoid some of those problems because you're not allowed to send in a null reference, basically, as we'll see. But under the hood, they're the same thing as pointers, right? I'm passing a memory location. Syntactically, the compiler's doing some magic. They're less versatile, but easier to use. They're supposed to protect against null references, but if you're determined, you can do it. I've done it. So outside of parameter passing, we can also use references. So I can declare a variable x equals 10, and then I could say, well, give me a reference y equals 10. So what happens is I made a variable x. I've allocated some space for it. It has a name and a value. And then I said, well, y equals x. This does not create a new variable y. It gives this variable a second name, right? So my writing is very bad, but now I can refer to this variable by the name y or by the name x, okay? And this is known as an alias. When I'm declaring references outside of parameter passing, I have to initialize it right away. So I cannot just declare int y. The compiler is going to complain about that. So you can do this. I'm not sure what use case this would serve, but let's see an example. Typically, though, references are used for passing parameters by reference. So here, I'm going to make two ints, n1 and n2, and then I'm going to make a reference r2 is equal to n2. Now, at this point, if I ignore everything under here, I've in some sense declared 3 variables, but only 2 variables exist, right? N1 and N2 are the only 2 variables that exist. R2 is just an alias for N2. So when I give N1 and N2 a value and then print out all 3 variables, well, we're going to see that N1 is 7, N2 is 99, and R2 is also 99, because they're both basically the same variable at this point. If I change R2 to 10, then in the next line, well, N2 has also changed to 10, right? So again, these are just 2 variables pointing to the same memory location. They have the same value. They're in some sense the exact same variable. And then R2 equals N1, so then I can give them all the same value. Now they all have the value 7. Okay, so you can use references like this. Again, I'm not sure why you'd want to. It's probably a use case, but I can't, off the top of my head, think about it. Think of one. References, when I declare them, I have to initialize them right away. I can't just have a dangling reference, right? It has to be, I have to assign it to point to another variable. So yeah, questions? Okay. All right, so that is basic language features. All right, let's talk a little bit about, I'm going to touch on graphics. All right, so in some sense, assignment 1, I give you this X11 extra technical challenge, right? And it shouldn't be too bad, but so I'm going to briefly talk about, I guess, what's expected of you on the assignment in terms of X11. Now, it should be noted, so let's open up. Let's take a look at this for starters. So this is the code that I gave you. Right, there's a bunch of tests that you run, so part of it is auto-graded. There's a bunch of menu items. You can, choose which test you want to run. You can run them individually, or you can run them all at once. There's a couple places where a TA is going to manually inspect what you've made. So in this case, it's going to test, it's going to make a window and try and render it. And then the TA is going to look at it and see if you've done that correctly. Okay. But you'll notice this is 6 marks out of 28. So without even touching X11, you can get 22 out of 28 marks. Okay, so like don't let the complexity or, maybe it's nothing to you, which is great. Maybe you want to try like ChatGPT and see if you can integrate that. This is a good, as far as I'm concerned, X11 is a lot of boilerplate and a few useful functions. And if you could get something to generate the boilerplate for you, good on you. Like that's what it's for, right? So maybe you want to try that as well. But if you do, you can do the whole thing just as like, I just hold this panel and these buttons and I give them values, but I never draw them on the screen. You can still get 22 out of 28, right? So don't let the X11 stuff scare you. If you're not comfortable with it, just get started on the regular stuff and then tackle it at the end. The other thing is I asked you to write 4 tests, right? So these are rendering tests, but if your rendering code's not working, just pretend it works. Just write some tests. Explain what the test does, right? So do a cout, this test, I'm testing for blah. And then give me some, they should have at least 2 panels and at least 2 buttons, and then test something and then move on to the next test. You do that 4 times, you get 4 marks. I mean, I'm not even going to evaluate the quality of your tests so much. I mean, there's maybe some minimum standard there, but just put 4 somethings and what you're testing for, and you should be good. All right, questions? Okay, I will, let's take a short look at X11. You may have seen this in 2401. But I'm going to just give you a brief overview, a very quick explanation of minimally what's expected to make an X11 app. So first of all, you have to include the X11 library. So x11/xlib.h. If you are using, some of you I kind of like sort of encourage to use a Mac and sort of run natively. If you're doing that, there's instructions in the make file that I gave you, right? So you'll have to add some extra flags because on the Mac, this file exists, but it's just not in the same place that it is on a Linux machine. And in fact, by default, your Mac's not going to know where to find it. So you put an extra flag, say like, look here for this, and then when you link it, you'll look at another place, which we'll talk about in a second. So what you have to do, you have to make, again, this is what I talk about when I say boilerplate. There's a bunch of like code. It's like, yes, there are reasons for it, but like, why couldn't I streamline this? Which is what we're doing, right? We're making a library that handles all this for somebody else. But you need minimally a display, a window, and a graphics context. Then you can call open display, right? You pass in a null. I forget what this does. Again, this is a good, a good use case. Well, I gave you some documentation, but I gave you Mark's notes, and I put up my slides from Mark's notes, so you have some references, but generally speaking, this is the kind of stuff I have to look up all the time, right? I don't know off the top of my head why this is null. I'm going to create a window. So this is a connection to the X11 server. So it's based on a server client architecture, which is one reason why we can run it over OpenStack. I create a window. Here, this will explain the things. This is quite a small window here. I'm going to give it a name. I'm going to create a graphics context. All right, so when I'm creating, these are the first things I need to do to put up a window on the screen. Then I'm going to map the window to the display. So this is, I'm going to say like, take this window, map it to the server, and then, try and print everything. X11 is notoriously, there's timing issues there. So sometimes I think I recommended in your draw function that you sleep a little bit at the beginning of the draw function, just in case some other stuff is happening in the background that needs to finish. And you'll have a lot better results with things actually showing up on the screen instead of just like giving you a white window. So flush, here I had to add some more time so that things get drawn. And then draw rectangles. A lot of what you draw is going to be rectangles and text. Set the foreground. This is the color of the rectangle. Here, this is going to be yellow. Fill rectangle, right? So yeah, 10, 90, 100, 100. So in the X11 universe, my window 0, 0 is top left, which means that X grows from left to right, goes from 0 up to whatever this happens to be, let's say 200. And Y grows in the downward direction. So I go from 0 to, I think it was 160 or something, at least in this example. Okay, so be aware of those that coordinate system. And then I can fill a rectangle. Set foreground means set the color, and then I can fill a rectangle. I can, I guess I filled two rectangles. I can draw strings. I can draw an image string, which is just something slightly different. And then I'm going to pause, wait here for the user, and then I'm going to close everything down. Okay, so there's a bunch of boilerplate at the beginning and at the end. That's kind of should go in your constructor and destructor. And then in the middle, this is sort of you drawing stuff. So let's see what this does. Whoops. I'm just going to compile this directly. Okay, so very simple output to example, example.c. Of course, it doesn't know what I'm talking about. So X11, you do have to link, right? So I have to say LX11, capital X. So this means that, right, we talked about compiling to an object file and linking it. That's exactly what this is. Well, not quite. It's a slightly different format, but it's an archive that's made from object files. So yeah, this will link it. It will compile. And then I get a little window that draws a little rectangle. And then it changes a little bit. It is really small, eh? All right, well, zoom in, I guess. I would have to change the font size and stuff. I would have to look up how to do that. So that is way smaller than I expected, but I drew a rectangle, a yellow rectangle, then I filled in the back with black. I drew another rectangle and then drew some text on top of it. Okay. So yeah, I expect you to do something like that, which means that you have to have X11 installed. Here, this is Windows Subsystem for Linux. If you update it or just install it fresh, it will have X11. Okay, so then you don't need to do anything. If you're using OpenStack, or if you're using your virtual machine, you're fine. You have X11 built in, you're good. If you're using OpenStack, then I have to connect from an environment that has X11 installed, which means that if I SSH in, I should SSH in maybe from Windows Subsystem for Linux. Right. So I'm throwing a bit of a curveball at you here. You're going to have to do some configuration. So feel free to ask questions. Try it early. Try and get it working. Whatever the problem is, we'll resolve it. If you're running on a Mac and you're running OpenStack, you just install, it's called Xquartz, and you'll be fine. Right, so Xquartz, that installs X11. It installs it in a weird place, but if you're going to SSH in, it's not going to matter. Again, I'm kind of throwing a tech curveball at you, and I'm kind of doing it on purpose so that you kind of have to do some research and, try out your large language models, see how useful they are, things like that. All right, questions? Okay, so that's your assignment one. Okay. That brings us to programming conventions. So we looked at, basic language features, and now this is a very short topic, and it's only about making your code readable. Okay, so C++, it's meant to be interpreted by humans. It's made for humans, and then we compile it into something that's made for machines. But in addition to choosing, well, there's a bunch of conventions that sort of people expect from you. Now, wherever you work, they're going to have their own conventions, but will we have enough material to do the assignment one after today's lecture? We still have to get to, technically we have to get to classes, eh? That's a good question. I'm going to say, how do we have half an hour left? I'm going to say early next class, you should have enough. Some of it you're going to have to pick up along the way, like constructors and destructors. We're going to cover them in detail, but you kind of should know how to at least use them, right? We're going to cover okay, you can make one and you can call some functions inside of it. But yeah, well, I'm going to keep an eye on this stuff, so don't panic. The calendar can change if things evolve differently than I expected. So don't panic. Keep me informed. If you feel like you don't have enough knowledge to do something, just let me know, and we'll work something out. But yeah, that's a good question. I will keep an eye on it. So every place you work is going to have its own conventions, and you should kind of follow them. There are some that are sort of widely adopted. That doesn't mean that you will necessarily be using them wherever you work, but the idea is we want our code easier to read. We want to keep things consistent, sort of if there's a naming convention for a function, you kind of want to keep with the naming convention of the library that you're building or the place you're working or whatever. These are communication tools, right? So when I write my code, you write some code, I look at it, I can read it, and I don't have to like try and figure out what sort of formatting you used. All right. So constants should be uppercase, okay? So if you make a constant and they are, it's quite a good idea, instead of writing magic numbers in my code, that I actually put like, oh, this is like max array, right? So when I just put 5 there, that's called a magic number, which means somebody looks at it and goes like, what is this? I don't know why this number is here. When I wrap it in a constant, then they can look at it and say, oh, okay, this is like the maximum you're going to allow somebody to, the biggest array that somebody can make. So we can also separate words with an underscore. Typically, variables begin with a lowercase letter. Some of these conventions are falling by the wayside with with different IDEs that do like highlighting and coloring. So these used to be like more important, but I've seen these conventions broken a lot more recently because of text highlighting, I'm guessing. Camel case or underscores if I have multiple words. So camel case means I use uppercase on the next word, even though it's all sort of appended together, or I can use like underscores. Names should be self-documenting. So you try and give people hints, right? Don't use this N instead of name. Like N could be a lot of different things. Windows is one of the, actually maybe not Windows per se, but like old Linux code is terrible for this. It's all short forms of this and that. You can use the scope as context. If I have a student class, I don't need student ID. I could just put ID, and I understand it's student ID. So I want to like be informative without being too long, although there's nothing wrong with a long variable name. Single lowercase letters are used for looping. Yes, I'm going to get to that today, probably. Data types or classes begin with uppercase letters. Okay, if you look at the standard template library, this is not the case. So it's like, obviously somebody's breaking this rule. But generally speaking, that's sort of, I guess, we'll call that a classroom convention. So when you make a class, I expect you to use uppercase, because I use it in the tests. So functions should begin with a lowercase letter. And again, camel case or underscores for compound names. White space, so indentation, right? It should look something like this. So it promotes readability, usually used to denote a block, right? So this is a block of code. It's all indented. It reads nicely. The nice thing is with IDEs, I could do like Control A, select everything, and then like right click and like fix my indentation, right? It'll do everything for you. So a block is a sequence of statements between pairs of braces, which we've talked about. There's also nested blocks, blocks within blocks. And so all of your indentation should match up, right? So if I have a block here, I want to indent this far, and then maybe I start another block. Well, I didn't give myself enough space. But I would indent this far now. And then if there was a second, I would indent the same way again. I'm not the best artist. I don't know. Hopefully that looks good. So yeah, the nesting level of a block is the depth from file scope. So every block at the same nesting level should have the same indentation. Acceptable styles of brace indentation. So you can do this, which is my favorite. You can do this, which my ID is set to. So you might see either of those from me. You can do like a little inline block, so one line of stuff here. So those are the 3 basic acceptable ways to write your blocks. How much should you indent? It's up to you. Just be consistent. 1 tab is not always portable between editors. Good grief! And if I have to, every time I copy and paste a Python file, I inject some space somewhere or tab or there's some things that are not. Oh, it's awful. So yeah, try and be consistent with your spaces and tabs. Comment blocks. Yeah. So I really like the way Java handles comments, in that they have sort of an official like documentation comment, and that goes into a Java doc. Other than that, I would say use comments sparingly. Like here or there where things need to be clarified, absolutely, but write good code. That's it. Write readable code would be my take. Obviously, a block of comments in the main function, specify authors. The other thing about this class is I give you the specification, right? So assignment 1, I give you the document. So I don't really need you to copy all of that information into your code in the sense of making comments. The other thing is, so just satisfy yourself. Try and think about like when I come back and read this, am I going to understand it? The other thing, it's hard to get. There's some TAs that really like comments, and if you give marks for comments, then they really go to town, and then other TAs don't care at all. So yeah, getting consistent marking is really hard, and I've kind of given up. Just aim for readability. All right, so different types of comments, part of a line. If I have a short comment, 1 or 2 lines, I can do it like this, right? And if I'm doing like some weird math function that it's not going to be very readable, then I should sort of put, here's what I'm doing for somebody else who comes along. If you need a larger comment, it should look like this. These are optional, but they're not optional in terms of the look, but it'll work without them, right? So, but you should kind of put them there. Don't use structs in this class, okay? Use classes. We're trying to reinforce this principle of least privilege. Try not to use too many global variables. Again, if I'm using a global variable makes a difference between your code working and not working, then use the global variable, right? And hand it in and lose the 1 mark for that and get the rest of the marks. Don't use too many global functions. You're going to see that we need to. Don't pass objects by value. Pass them by reference, right? So we just saw the example of references. I expect you to do that with all of your objects except for strings, right? Strings are an exception because, it's a special case where you have like you have string literals that you have to deal with, and they complicate things. So for strings, you can pass by value. But for an object, you should pass by reference. So it should look something like that. Do reuse code whenever possible. We're going to talk about refactoring later. Do perform basic error checking, okay? If I tell you a value should be in a range, in the setter and in the constructor, you should check to make sure that value is in that range. Okay, so that's, again, a small amount of marks, but there are marks for that. All right, questions? Okay, let's get into some classes. Okay, so class definitions. So, well, to start with, we're going to talk about what a program looks like in C and what the equivalent program looks like in C++. Now, the idea behind C++ is they should compile to be the exact same thing, whereas C++ should be easier to write, though, right? So that's sort of the idea behind it. We're going to talk about access specifiers, private, protected, and public, class members, member variables, member functions, code organization. So how do I split a class into header and source files, variable scope, and namespaces? Again, if we don't get through everything, don't panic. The schedule is flexible, right? We'll make changes if we have to. So C++ was once known as C with classes. Wait, let me see if I got any. Yeah, still got no questions here. So yeah, so we're going to start with some C-style code, and then we're going to move to object-oriented code and like look at the differences and philosophically explain why we made these changes, right? So these 2 types of code are going to work exactly the same. So I have we're the B section. I forgot to make a copy. It should be fine. Oh, no, sorry, this is the wrong file. Okay, we'll start with P1. P1's too much. So P2. So this is C++ code, but let's write it in a C style. So I'm going to make, I have a university and I'm going to store some students. Here's all the information for the students, and I want to store them in a student struct, right? That's typical C. And then I'll have some functions that operate on that struct. So I define well, I could use struct, but I'm going to define a class and I'm just going to make everything public, right? So this is functionally exactly the same as a struct. It just has some members and they're public. I can just access them from any student. And then I have a function that operates on students. I said we'd use the C style, but I'm using a reference here instead of a pointer, right? Again, I want to pass objects by reference. It saves, right? A reference is a memory location. It's 8 bytes that I have to copy, whereas a student is like 3 strings and a float, and that is, well, it's more than 8 bytes, right? And of course, they can be like arbitrarily large. You don't want to copy when you don't have to. I'm going to make an array of students. This is a statically allocated array of students. This is the same type of array I asked you to make in assignment 1. I asked you to make 2 different arrays. They're both like this. Different classes, but the syntax is the same. I have a bunch of information, and then I'm going to, well, I don't know, step 1, I'm going to initialize all the student structs using these, using these arrays. And then I'm going to print all those students. I'm just going to call the print function and pass the students in by reference. I'm going to print all the passing students. I'm going to say, well, if the student GPA is less than 6.0, they're failed, so I'm going to continue. I'm going to skip that one, and otherwise I'm going to print that student out. And that's it. So I'm going to do those 3 things. Initialize the students, print them all out, print out all the passing students. I only have 3 students, but I think Barb is failing. Yeah. Okay. So I initialize, so, the formatting here is pretty ugly. So I initialize all my students, I print them all out, Joe, Amy, and Barb. And then I print out all the passing students. Well, that's just Joe and Amy. Barb's got a 5.9. Okay, so this is the C style. Everything's public. I use structs. I use functions. Let's change this to the equivalent in object-oriented programming. So, well, the first thing I can do is say that print function, it only operates on students. I'm going to make it a member. It's a member function now of my student class. Everything else is still the same. But when I call print now, I have direct access to the members of this class. I don't have to pass in student by reference and then grab the individual variables. I can just access the variables directly. But otherwise, this works more or less the same. I just have a for loop. The format of this is different now. I say students.print instead of print this student. But everything else is the same. GPA is the same. And the output is the same, right? So printing all the students, Joe, Amy, Barb, and here I have Joe and Amy, all the passing students. So let's take that a step further. Instead of initializing students explicitly, I'm going to pack that into a constructor in my student class, right? Because I'm exposing, what I'm doing here is I'm exposing a lot of implementation details, and I actually kind of want to hide these things. Even though it's very straightforward, there are benefits to doing so, which we'll talk about. And this, well, student GPA, if they're failing, my GPA is less than 6. But so maybe I call this piece of code in multiple places in my program, and then Carleton goes to a 4.0 system, right? So now I have to go through all my code. I have to change this from less than or equal to 6.0 to less than or equal to less than 2.0. So what I want to do is I want to put that in my class as well, which means that if something changes about, the requirements for a passing grade, I have one place to change that, right? I go to my student class, and I change how that is, I can change my isPassing function. So instead of exposing those implementation details that the GPA must be at least 6.0, I just say, is my student passing? I've abstracted that away. Now, if the mechanism for student passing changes, I can go to this one place and change it, and the rest of my code still works. Right? So this is one of the principles behind encapsulation, is that I'm making my algorithms general and robust. Right? So here now I initialize all my students, I print all my students, I say if they're passing, print them out. I delete all my students as well, we'll get to that, but the student becomes more generalized. Like I'm worrying less about implementation details and just saying, no, just print, right? You figure out, student class, you know how to print, so you figure it out. Is my student passing? Again, that's the business of the student class. I don't know necessarily what it means to pass, and I don't have to know what it means to pass in order to write this code. Right? I can just say, well, I'm going to use this. And so now we have, when you compile it, it compiles to the exact same code as before. That's the dream, at least. But now I have encapsulated all these implementation details. So technically, I don't have to tell you how I'm printing. I don't have to tell you how I'm initializing or is passing. I don't even need to tell you my member variables, right? They're private now because nobody needs to access them from outside. Your only access to my student member variables is through these public functions, which is safer in some way, right? Somebody can't come along and change the values arbitrarily. They have to call one of these functions, and I can make sure that they're changing it correctly, right? They're not going to say, change my GPA to 13 when we run on a 12.0 system. I can verify stuff like that. All right. Questions? Okay. If you look at, so here's again, this is a student. I have a constructor and I have a print function that, just prints student. And I've changed the strings to chars because this little tool that I'm using, strings come with a lot of extra baggage, and these are easier to read. But there is a little tool using Clang that outputs, where is it here? So I can see what, I've changed the struct into a class, but I want to see what the difference is in terms of memory layout, and it's the exact same thing. So my student class in memory, it's still just a struct. And the functions that were once global functions, they're member functions, but they're still, basically, when I compile them, they go into the code segment. They take a student as an argument. So the C code and the C++ code should compile to the same thing. The difference is now I have better encapsulation in my C++ code. All right. Questions? Okay. All right, so we've shown how to make, this is, your first step down the object-oriented programming pathway. So why do we care about, why do we care about encapsulation? Why do we care about hiding these implementation details? Well, basically, when you're working in industrial grade code bases, they're very big, right? So Windows is like, I think it's a few million lines of code, right? So millions of lines of code, like no joke. Hundreds of libraries and packages. We want to protect our code from unauthorized changes, but we also want to sort of separate complexity where it belongs, right? So like I said, the student class, if isPassing changes, I have to go into my class and make one change. Whereas if I expose those implementation details, then everywhere I called that GPA greater than 6, I have to go and change that code. So I'm sort of making it so that changing the code is easier. And to do that, I'm going to restrict all access to unnecessary details whenever possible. This is called the principle of least privilege. So what it means is that I have these access modifiers, private, protected, and public, and I should be as private as possible. I should never expose any detail if I can possibly help it. You have to have some public-facing functions, otherwise you can't use your class. But only the stuff that is absolutely necessary. Right? So an example is a car. Like if you're not an expert in automotive repair, you know, maybe you want to pop the hood to like fill up your washer fluid or whatever, but you're not going to go like change the timing belt if you're not an expert. So there's a hood that's kept like sealed away from you. Now you can open it if you want to, but of course you generally speaking don't. You get in the car and you have this nice interface, you have a steering wheel, you have the gas pedal, you have the brakes. How does that all work? Like you don't actually need to know that. You just need to know that it does. Right, so that's like an interface that we want to present to people. We're going to say like, here's something nice and pleasant to use, right? Steering wheel, gas pedal, brake. You don't need to know how to use it, but here's how it works. Like here is how you would use it. How we implemented it, you don't need to know. So public access, a class member is visible to all objects and global functions. Protected access, class member is visible by subclasses only. This is different from Java. Okay, so Java is protected trying to remember what Java is. It's like package level, right? Is that right? No, there's two things. There's like default, and then there's protected, they're slightly different. Anybody know? No? Yeah? For Java? Yeah. Subclasses. I think Java has to do with packages though too, or something. I don't know. I don't remember. Anyway, C++ is different. It's protected as just subclasses, no packages, right? And there's no default. Protected as package access. Okay. So yeah, even if you have I think it's in Java, even if you have like a child class, if it's outside of the package, it can't access protected members, something like that. Anyway, in that way, C++ is a little more straightforward. So we only use protected when we're using inheritance. It never comes into play any other time. Private, not visible to other classes or global functions. But there is a big difference. It's visible to other members of the same class, right? In Java, that's not true. If I have student and it has a private member variable, student number, and I have a student.access member variable function, and I pass in another student, like I cannot access that private member variable, but in C++ you can, which we're going to see is actually quite useful for a lot of the things that C++ does. So to define my class, I use the class keyword, followed by the class name, followed by braces, followed by the semicolon. So in my class here, I mean, I didn't really point it out, but this semicolon, this might save you wondering why your code is not compiling. So do remember to put that. In the class block are the class members, data members, and member functions, right? So inside my class block, I have my data members. I also have my member functions. The constructor is just the function, right? It's called at special times, but it is just a function. We can use access specifiers to partition members by access level. So instead of individually declaring things public, I just have this public block. So everything following this declaration of public is public. And then I have one for private, and you can put them wherever you want. If you do not put one, it's private by default. So if I forget to put this, right, the compiler is going to complain like, I can't make this student because your constructor is private. So that's another bug to watch out for. All right, so yeah. So in memory now, objects follow the same rules as, how much time we got? 5 minutes. Okay, so objects follow the same rules as any other variable, right? So we saw int, and we talked about how that's a statically allocated variable. Well, I can do the same thing with my student class. I just declare the type and the variable name, and that's a statically allocated student. It goes on the stack, right? In Java, you don't have choices. Java, any object you make with the new keyword, And it goes wherever Java decides to put it, mostly on the heap, sometimes on the stack. But for us in C++, we decide where it goes, right? So this would be statically allocated. If I declare that as a local variable in a function, it goes on the stack. I also have the option of doing the Java style initialization. So I'm going to use new here. In this case, new behaves a lot like malloc. It's going to allocate some memory for me automatically. The difference is this new will also call the constructor on that memory, right? So it's going to, there's a chain of things that happen that allocates memory and initializes it for you. So yeah, don't use malloc. Please use new in this class. Anytime I use new, that goes on the heap. Every single time, no matter where I use it. And then it stays on the heap until I call delete. So again, for the first assignment, you don't have to do this. You can if you like, right? Experiment with it, play with it. We're not checking for memory leaks, so you feel free to like burn up your heap or whatever, but you don't have to. You can just use statically allocated. It all cleans up itself. So a class in C++ consists of two files, a header file with the .h extension and a source file with the .cc extension. So let's briefly look at that before I let you go. So now I have a student class declaration, but I did not put the function implementations, right? So the previous example, I had the implementations inside the class, but now this is just the declarations. I still include the memory variables, but this is this is a definition of a class. It's enough for the compiler. And then I'm going to write these into my, I'm going to have an implementation file. So I'll show you it. We'll go over it next class, but it's going to look something like this. Basically, I have the scope resolution operator. I tell the compiler this is part of the student class, and then I have the implementation. And then we'll look at how to compile that and link it to my code. We'll do that next class.